Good morning. So, are we live? Let me check. Am I audible? Am I audible? Yeah. All right. So, good morning and welcome to another session of this Crack NEET 2022 series. And sorry for the interruptions, okay, that had happened in between. And we'll continue with the series. All right. So, uh, the topic, the chapter that we are going to discuss today, it is the rotational motion, and I have broken it down into two parts because it is a big chapter and there have been lots of questions asked on the rotational motion. Okay, so let's begin. So now in this chapter we mainly focus on the rigid body dynamics. So what is a rigid body? It is an idealization of a body that does not deform or change its shape. That means if you exert an external force on this body, there won't be any change in the shape or size of this body. So what will change? Only its linear motion, only its acceleration in linear motion or in rotational motion. Okay, so that means the external force will only accelerate this body, okay, if it is performing linear motion, or if it is performing rotational motion, then it will impart it angular acceleration. Okay, those are the things that will change. Yeah, hi strangers music. All right, so now there is an important concept regarding the rigid bodies. Okay, the concept is center of mass, and this is an important concept because it allows us to to it allows us uh, to understand the rigid body dynamics. Okay, just like we studied the motion of a single particle. Okay, so the center of mass, it makes this rigid body kind of a single particle. Okay, let's see how. So it is the point at which the whole mass of this body is supposed to be concentrated. Okay, so what is center of mass? It is the mass at which we suppose that the whole mass of the body is concentrated. So if we have a two particle body and they are at positions r1 bar and r2 bar, then their center of mass is given by this formula. Okay, this is the position vector of center of mass, m1 r1 bar plus m2 r2 bar divided by m1 plus m2. Okay, and if masses of those two particles is equal, if m1 is equal to m2, it's equal to m, then you can take m common from numerator and denominator, you can cancel it out, and the formula that you will get is the position vector of center of mass is r1 bar plus r2 bar divided by. Okay, after that, if you have n particle systems, so this was for two particles, if you have n particle systems, then you can easily generalize this formula. Okay, so position vector of center of mass of n particles is m1 r1 bar plus m2 r2 bar plus so on and so forth up to plus mn rn bar divided by sum of masses of all those particles. So it is m1 plus m2 plus m3 so on and so forth up to mn. Okay, and you can write it in this compact form. So summation I goes from 1 to n mi ri bar divided by m, where this m is sum of all these particles, sum of the masses of all these particles, that is the total mass of the body. Okay, so then next, this is for the position vector. In similar fashion, you can find out the coordinates of the center of mass. So what are coordinates? So if you want to find out x coordinate, it will be summation of mi xi. Okay, where I goes from 1 to n, m1 x1 plus m2 x2 plus m3 x3 so on and so forth up to mn xn divided by m. Okay, Y coordinate is summation of mi divided by m. Z coordinate is summation of mi zi divided by m. Okay, and if you have some symmetric body, then finding out the center of mass of symmetric bodies is very simple. It is just their geometric center. Okay, so for an example, if you have a ring, what will be its center of mass? It will be center of the ring. If you have a disk, its center of mass will be center of the disk, so on and so forth. Okay, so for symmetric bodies, the center of mass is just their geometric centers. All right, after that, so now in case of linear motion, the quantity that governs the motion is force. So in case of the rotational motion, the quantity that governs the motion is torque. So what is torque? Torque is also related to force. So torque is defined as moment of force. So what is moment of force? So torque is defined as, let's say you have some body, okay, you have this body and you are exerting some force on this body, let's say at this point. Okay, so this is your force. All right. So how do you find torque? So let's say this is the origin and this is the position vector of this point with respect to the origin, r bar. So torque is defined as the vector product of r bar and f bar. Okay. So how do we find vector product? So we write vector product using this determinant, the determinant of these three rows. So first row is I, j, k, the unit vectors along x-axis, y-axis, z-axis. Second row is rx, ry, rz. Okay, the components of this vector along x, y, and z-axis. And third row are the components of the second vector along x, y, and z-axis. So I hope you know how to solve this determinant, and in case if you don't know, so this is the solution of the determinant. And how do we solve it? So let's say you write I cap, okay, then you hide the row and the column containing I cap, then you multiply this ry with fz and rz with fy. Okay, so that will be your first term, okay, in the solution. All right, so ry into fz minus rz into fy. Then you write minus j cap. Okay, so sign of the y component will be negative. So minus j cap. Then you perform the same procedure. So you hide the row and the column containing j cap. Then you will be left with these four terms. So you multiply this with this and this with this. So rx into fz minus rz into fx. Okay, so that's your second term, rx into fz minus rz into fx. Okay, and similarly you write plus k cap and you hide the row and the column containing k cap. Then it is rx into fy minus ry into fx. Okay, so that is how we find the resultant of vector product of two vectors. Okay, so this is in vector form. Now let's suppose you just want to find out its magnitude. What will be its magnitude? So the magnitude is given by this formula. In scalar product, it is magnitude of first vector, magnitude of second vector multiplied by the cos of the angle between two vectors. Here it is magnitude of first vector multiplied by magnitude of second vector multiplied by sine of the angle between two vectors. Alright. So and one more thing about this resultant of the vector product. So now we have three vectors. The two vectors we are multiplying with each other to get the third vector. Okay, that is the resultant of vector product. So what about the direction of this resultant? So the direction of resultant is found by right hand thumb rule. So it is perpendicular to this first vector as well as the second vector. Okay, so how do we find that? Let's say this is your first vector r bar, this is the second vector f bar, okay, and theta is the angle between them. So you are multiplying r bar with f bar. r bar cross f bar you are finding out. So you will take your right hand, put that right hand in direction of first vector and curl your fingers towards the second vector and stretch your thumb. So your straight thumb will give you the direction of resultant. So now, right now, if your mobile or any device you are watching this video in, if it is lying down, then the resultant will be upwards. If it is kept in front of you, then r bar cross f bar. Okay, and if you stretch your thumb, okay, so straight thumb will show you the direction of resultant, and it will be pointing towards you. If it is lying down, your device is lying down, then r bar cross f bar, it will give you what? Vertically upwards direction. Okay, so I guess you could find that. Yes, no? All right. So what does this torque measure? Torque measures the rotational effect of a force. Okay, so for an example, if there is some body which is rotating with a constant angular velocity, or there is a body which is at rest but which can rotate about some given axis. Okay, so if more is the torque, more will be the angular acceleration. All right, so that is, if torque is more, there will be more change in rotational state of motion. So in that sense, the measure of rotational effect of force is torque. Okay, I'm sorry. All right, so now there is another important quantity known as angular momentum. So what is angular momentum? So angular momentum for a single particle, for one particle, it is defined as the moment of linear momentum. Okay, so in same fashion that we have defined moment of force, what is moment of force? It is torque. So it is r bar cross f bar. So moment of linear momentum is r bar cross linear momentum. So it is r bar cross p bar. Okay, where p bar is mass into velocity. We know this. Okay. Then there is law of conservation of angular momentum. So angular momentum of a body remains conserved if torque acting on the body is zero. Because what is relation between angular momentum and torque? So just like for linear motion, force is given by what? It is rate of change of linear momentum with respect to time. This is Newton's second law. We know this is Newton's second law. Okay. So in same way, in rotational motion, the torque is given by dl bar by dt. All right. So so the rate of change of angular momentum with respect to time is equal to what? Torque. Just like rate of change of linear momentum with respect to time is force. So this is Newton's second law for rotational motion. And if torque acting on a body is zero, then there will not be any change in the in what? The angular momentum, because dl bar by dt, change in angular momentum will be zero, and that means the angular momentum will remain constant. Okay. After that, we'll discuss equilibrium of a rigid body. So now, before this chapter, there was only one condition for equilibrium, because we studied only linear motion, right? So in case of linear motion, what is the condition for equilibrium? So if body remains in equilibrium, that means sum of all forces acting on the body is zero. So if body is at rest, it will remain at rest. If it is moving with some constant velocity, it will keep on moving with that constant velocity. Okay. So similarly, if sum of all torques acting on the body is zero, then body will remain in rotational equilibrium. And what does that mean? If body is at rest, it will remain at rest, it will not rotate, it will not start rotating. And if body is rotating with some constant angular velocity, it will keep on rotating with that constant angular velocity if the net torque acting on that body is zero. Okay. So this is equilibrium in rotational motion. After that, there is a point So we discussed about center of mass. There is another important point in rotational dynamics, that is center of gravity. Okay, so what's that? So it is the point at which the torque due to the gravitational force is zero. Okay, so let's say you have a body consisting of n number of particles, n number of masses. So this is m1. Okay, the gravitational force on this particle will act like this. Let's call it f1 bar. Okay, it will be m1 into g. This is some m2. The gravitational force will act like this. So there are n number of particles like this. So let's suppose this is the point for which the gravitational torque is zero. Okay, gravitational torque about this point. That means if you draw position vectors of all particles considering this point as a origin, let's call this origin. So this will be r1 bar, okay, directed like this. Then r2 bar will be directed like this, so on and so forth. Okay, so how do you find torque? So torque due to F1 will be R1 bar. So I have drawn same position vector, okay, but at this point. So this is R1 bar cross F1 bar will be the torque due to F1, and it will rotate the body in which sense? So it will rotate the body in anti-clockwise sense. Now if you take this R2 bar and draw it over here, okay, this is R2 bar, okay. So torque due to this one, it will try to rotate the body in clockwise sense. So if torque due to all these forces, all the gravitational forces acting on all particles within the body, if they are balanced, then this point is known as what? It is known as the center of gravity. Okay, so center of gravity is a point in body about which gravitational torque is equal to zero. All right, after that, so next important point is moment of inertia. So what is moment of inertia? It is the measure of rotational inertia of a body. So just like in linear motion, mass is the measure of inertia. In rotational motion, moment of inertia is the measure of inertia of a body. And how do we find that? So let's say we have n number of particles, system of n number of particles, which we can measure. Okay, so we can measure number of particles. Then the moment of inertia about that system is given by summation of mi ri square, where I goes from 1 to n. So it is number of particles. So let's say you have system of these two particles. Okay, so you want to find its moment of inertia about this axis, about this vertical axis. All right, so this is mass m1, which is at perpendicular distance r1 from this axis. This is mass m2, which is at distance r2. So what will be its moment of inertia? It will be m1 r1 square plus m2 r2 square. Okay, so this is for the discrete mass system. And if you have some continuous mass distribution, so where you cannot count the number of particles, then in that case the moment of inertia is given by this formula. We find it using this formula. It is integral of r square dm. So we take n number of small masses, okay, dm, over that entire body, and we find moment of inertia of that all those masses, and we add it up, okay, continuously. So this continuous addition, as we know, it is the integration. Okay, and if we do that, So can you see me? Okay, actually there was a power cut. All right, I'm sorry, there was a power cut. So let's continue. Okay, so where were where were we? So for continuous mass distribution, the moment of inertia is given by this formula. I equals to integral of r square dm. Okay, and here are a couple of examples. Let's say you take a ring, then its moment of inertia is given by this formula. It is I equals to mr square. Okay, where m is mass of the ring and r is the radius of ring. So moment of inertia of ring about this axis, this perpendicular axis which is passing through its center. It is given by this formula. Okay, and let's say you have a rod, a very thin rod, then its moment of inertia about this axis which is passing through its center, it is given by this formula. I is equal to ml square divided by 12. Okay, so then there are couple of theorems on moment of inertia. So one is parallel axis theorem. I naught is equal to ic plus mh square. So what does that say? So let's suppose you have some body and you know the moment of inertia of this body about this axis which is passing through its center of mass. Okay, then you can find out its moment of inertia about a parallel axis provided you know distance between those two axes. So distance between those two axes is, let's say, h, then moment of inertia of this body about this parallel axis, it is given by this formula. IO, so moment of inertia about this axis, it is equal to moment of inertia about an axis passing through the center of mass, IC, plus m into h square, where m is mass of the body and h is the distance between those two axes. Okay. After that, next is perpendicular axis theorem. So the parallel axis theorem is applicable to parallel axis theorem is applicable to all kinds of bodies. The perpendicular axis theorem is applicable to only a specific kind of bodies called as laminar bodies or planar bodies. Okay, so the bodies which are very thin, you can keep them in a plane. So for them, the perpendicular axis theorem is valid. So what does that say? So let's suppose you know moment of inertia of this body about this vertical axis which is perpendicular to plane of the body. So you know moment of inertia about this axis. Okay, then the moment of inertia of the body about these two axes, let's say x and y axis, which are lying in plane of body. Okay, so if this is body, then x and y, they are lying in plane of the body. Okay, and all of those axes are concurrent, they are passing through the center of mass. Then you can find out moment of inertia about these two axes. So there is a relation between them. So iz is equal to ix plus iy is the relation. So this is perpendicular axis theorem. These three axes are perpendicular to each other. Okay, so the moment of inertia about an axis which is passing through the center of mass and it is perpendicular to the plane of body can be written as sum of moment of inertia about these two axes, x-axis and y-axis. These are the axes which are perpendicular to each other and also perpendicular to that vertical axis. Okay, and they are lying in plane of the body. So moment of inertia about those two is ix and iy. Then iz can be written as ix plus iy. This is the relation. All right. And then there is one more thing. And yeah, this is the last thing for the theory in today's lecture. And then we'll see the problems. So next thing is radius of gyration. So what is radius of gyration? So let's suppose you know moment of inertia of some body. Okay, you find it out using one of the two formulae, summation of mi ri square or integral of I square r square dm. Okay, then if you want to replace that body with a particle, okay, one particle having mass equal to mass of the body, and you want to keep that particle at such a distance from the same axis that it has same moment of inertia as that of the body, then that distance is known as radius of gyration. Okay, so let's say you have this body, its moment of inertia you find using this formula summation of mi ri square. Then you replace this body with one particle, single particle having mass equal to mass of this body. So at what distance you should keep that particle such that that particle will have same moment of inertia as that of this body. So that distance is known as radius of gyration. So here I am keeping it at distance k and I am claiming that it has same moment of inertia as that of this body. Okay, so this distance k is known as radius of gyration. So what does it give? It gives us the distribution of mass about a particular axis of rotation. It gives us distribution of mass of body about an axis of rotation. Alright, so I is equal to mk square. Moment of inertia of this one particle will be what? It is given by mass of particle multiplied by distance square. So m into k square. Okay, mk square, and if you take m on other side, then you will get I upon m equals to k square, and then if you take square roots on both sides, you will get k equals to square root of I divided by m. Okay, so just for the sake of an example, for a disk whose moment of inertia is given by mr square upon 2, if you substitute it in this formula, you can find out its radius of gyration. So radius of gyration of a disk, it is given by what? Square r divided by root 2. Okay, so radius of gyration of a disk is given by r divided by root 2. Alright, so I hope this is clear. Is there any question? No questions? Okay, so then we'll see some problems based upon these topics. Alright, so okay, let's see some problems based upon these topics. So first problem is two particles of mass 5 kg and 10 kg respectively are attached to two ends of a rigid rod of length 1 meter with negligible mass. Okay, the center of mass of the system from 5 kg particle is nearly at a distance of. So this is very simple problem. So let's say you have two particles like this, one particle of mass 5 kg, this is m1, and another particle has mass 10 kg. Okay, then you want to find out the center of mass of the system. Okay, by the way, length of this rod is 1 meter, and you want to find out center of mass of the system about from 5 kg particle. So you want to find it out from this point. Okay, so what will be distance of 5 kg particle from that point? It is 0. Radius of gyration. Yeah, radius of gyration, let's say you have a body. Okay, you know moment of inertia of this body. So how do you find it? Using some formula, summation of mi ri square, let's say you find out I, and you want to replace this body with one particle having same moment of inertia. Okay, and what is speciality of that particle? So you will keep it at some distance from this axis and it will have same moment of inertia. So that particle has mass equal to mass of this body. Okay, so I will take this axis, I will draw it here. So this is my particle. Its mass is equal to mass of this body. So at what distance I should keep that particle so that it has same moment of inertia as that of this body. So that distance is known as its radius of gyration. Okay, radius of gyration of this body. Got it? क्या नीला? Is it clear? All right. So I guess so. Is Nirala or Nirala around? Okay. So now let's come back to the question. So you have these two particles, masses are m1 equals to 5 kg, m2 is equal to 10 kg, and they are at distance of 1 meter from each other. And you want to find out the center of mass of the system from this point. Okay, this is the question. So it's very simple. So we know the formula of center of mass RCM. It's equal to, because this is one dimensional problem. Okay, will not consider vectors, right? So it is m1 r1 plus m2 r2 divided by m1 plus m2. Okay, good. So m1 is 5 kg. What is distance of this mass from this point? It's 0, right? So this will be 0 plus m2 multiplied by r2. So what is distance of m2 from this point? From this point, it is 1 meter divided by m1 plus m2. Okay, yeah, let's substitute m2 equals to how much? 10 kgs. It is 10. Okay, so m1 is 5 and m2 is 10. So 5 plus 10 is 15, and in numerator we have 10. 10 divided by 15 is what? 2 by 3. Okay, or you can write this as 0.666 will be recurrent, 667. Okay, in meters. And if you want to convert it in centimeters, because all the options are given in centimeters, so it will be 67 centimeters, right? So this is very simple. Okay, and it is from NEET 2020. So yeah, very simple question. Okay, let's move on to the next question. All right, two bodies of mass 1 kg and 3 kg have position vectors. These are position vectors of two bodies, and the center of mass of this system has position vector. So this is again very simple. So we have two particles. Position vector of center of mass is equal to what? m1 r1 bar plus m2 r2 bar divided by m1 plus m2. And mass of first particle is 1, mass of second particle is 2. It is 1 multiplied by, what is r1 bar? So this is our r1 bar. Okay, so 1 multiplied by I cap plus 2j cap plus k cap, plus we have m2 equals to 3 kg. So 3 multiplied by second vector is this one. Okay, r2 bar is minus 3 I cap minus 2j cap plus k cap, divided by, we have sum of masses of two particles 1 plus 3. So this is equal to, okay, so I cap plus 2j cap plus k cap plus 3 times minus 3 is minus 9, minus 9 I cap, 3 times minus 2 is minus 6, so plus minus 6 j cap, and 3 times k cap, so plus 3 k cap, divided by, in denominator we have 4. Okay, so it is I cap minus 9 I cap, so it is minus 8 I cap, right? So I'll write it here. So this is equal to minus 8 I cap, then j cap 2 j cap minus 6 j cap, so it is minus 4 j cap, and k cap plus 3 k cap, so it is 4 k cap, 4 k cap divided by 4. It's not going outside of screen, no. Okay, so this is equal to, if we divide it, it will be minus 2 I cap minus j cap plus k cap. Okay, because 8 upon 4 is 2. Okay, 8 by 4 is 2, 4 by 4 is 1, and 4 by 4 is 1. So minus 2 I cap minus j cap plus k cap. So which one? Yeah, option 1, option A, sorry, is the answer. Okay, this is simple. Any question in this? All right. So let's move on to the next problem. Two persons of masses 55 kg and 65 kg respectively are at two opposite ends of a boat. The length of the boat is 3 meter and weighs 100 kg. So its length is given, weight is given. The 55 kg man walks up to 65 kg man and sits with him. If the boat is in still water, the center of mass of the system shifts by. So see, this is a very simple problem. It is based upon a concept actually. So you have this boat and you have two people. This first person, his mass is 55 kg, so let's call it M1. Second person whose mass is M2, and boat has some mass, let's say M3. And now what happens is, so this person with mass M1, he walks to the person with mass M2. So then he sits there. Okay, so you can see some mass is shifting, right? The question is, if boat is in still water, so boat is in still water. So now what will happen to the center of mass? Okay, so by what distance the center of mass will shift? This is the question. And answer to this question is very simple, very straightforward. So answer is, since there is no external force acting on the center of mass, acting on the system, the center of mass will remain where it is. Okay, it will not shift. Okay, so since external force is equal to 0, there is no external force. The man is moving by himself. Okay, no external force is moving the man. So that means what will happen? Since no external force is there, if center of mass is at rest, it will remain at rest. If center of mass is moving with some constant velocity, it will keep on moving with that constant velocity. But since the boat is in still water, that means the center of mass is still and it will remain still because net external force is 0. Okay, so answer is this option C. Center of mass will not shift. So is this clear? Please reply. Okay, so we'll move on to the next problem. Is there some delay between what I say and what you see? There is no delay. All right, let's move on to the next problem. Two particles which are initially at rest move towards each other under the action of the internal attraction. Okay, so there is no external force. Again, this can be similar to the last problem. If their speeds are v and 2v at any instant, then speed of center of mass of the system will be. Okay, so two particles which are initially at rest. All right, this is exactly similar to the last problem. So we have two particles initially at rest. Mass of first one is m1, mass of second one is m2. They are moving towards each other due to the action of their due to their internal attraction. So you can say there is some gravitational force or something. Okay, so that is internal attraction. There is no external force acting on this system, and that means, so if initially the center of mass of this system was at rest, it will remain at rest, and because the two masses were at rest initially, then their center of mass was at rest. So since there is no external force, the center of mass will remain at rest. Okay, so it remains at rest. So question is, the speed of the center of mass is, it is 0. Okay, exactly similar to the last problem. Okay, just context is different, but it is exactly similar. Problem is exactly similar to the last problem. Okay, 2012, and this was from 2010. All right, so concept based question. Okay, then let's move on to the next problem. A man of 50 kg mass is standing in a gravity free space. Okay, so space is free of gravity, there is no gravity, at a height of 10 meters. So man is not standing, he is floating at a height of 10 meters. So floor is here, 10 meters above the floor. This is 10 meters. Then he throws a stone of 0.5 kg mass downwards with a speed of 2 meters per second. Okay, so he throws a stone from this height downwards with a speed of 2 meters per second. When the stone reaches the floor, when the stone reaches the floor, the distance of man above the floor will be. This is the question. Okay, so now mass of man is given, mass of stone is given, speed of stone is given. So now again we can say there is no external force on the system, so its momentum, linear momentum, will remain constant. So I can say initial linear momentum before the man threw that stone, it was 0, because man is steady, stone is steady. So initial linear momentum is 0, and therefore final linear momentum will be equal to 0. So mass of stone into velocity of stone, this is momentum of stone, plus mass of the man into, I will just say m, into velocity of man. So sum of that should be equal to 0. Sum of these two momentums, okay, is equal to 0. So what is ms? Mass of stone, it is 0.5. Okay, all right, I want to find out velocity of this man, so I will take other things on other side. So it will be minus ms into vs. Now we can substitute values, or we can take mass of the man also on the other side. So vm, velocity of man, will be minus ms divided by m into vs. So now we can substitute values. So what is mass of stone? It is 0.5. How much is mass of man? It is 5. Velocity of stone is 2. So multiplied by 2. So now 0.5 divided by 5 will be, oh, mass of man is 50, not 5. Okay. So 0.5 divided by 50. So this can be written as 5 into 10 raised to minus 1, and 50 can be written as 5 into 10 raised to 1. Okay, so we have this 2. So 5 and 5 gets cancelled. 10 raised to 1, if we take it in numerator, it becomes 10 raised to minus 1. So we can say that this is equal to 2 into 10 raised to minus 2, or 0.02. So minus sign just says that if this ball or the stone is moving downwards, the man will move upwards. Okay, so it is minus 0.02 meters per second. This is the speed. And so if this ball, it moves with the speed of 2 meters per second, in what time it will reach the ground? It will reach in 5 seconds. Okay, because let's add a page. Distance between the stone and the ground was 10 meters. Okay, so distance is 10 meters or height is 10 meters and speed is 2 meters per second. So time taken by stone to reach the ground will be distance upon speed. So 10 divided by 2, that is 5 seconds. So velocity of man is 0.02 meters per second. So now in that time, how much upwards the man will move? So shift in position of man. Okay, shift in height of man, we can say, in upwards direction. So it is the speed, the magnitude of speed only, because the man is moving upwards and we want upward shift in his height. So Vs, sorry, not Vs, Vm, the speed of man multiplied by time. So speed of man is 0.02 multiplied by time is 5. So this will be 0.1, okay, meters. So 0.1 is the answer. Yeah, but we want the distance of man above the floor. Okay, so man will shift with some distance 0.1, but we want distance of the man above the floor. That means height at which the man will be there. So earlier it was 10 meters and now he is moving further with 0.1 meter. So it will be, so distance above floor will be how much? It will be 10 plus 0.1. So it is 10.1 meters. Okay, yeah, option B. So 10.1 meters. So option B is the answer. Got it? Yes, no. Only one student is replying. All right. So this was simple. Let's move on to the next problem. Find the torque about origin when force of 3 j cap acts on a particle whose position vector is 2 k cap. Okay. So let's say, so in case of vector product, I missed one thing that I will tell you now. So let's say you have unit vectors along xyz axis. Okay, so this is I cap, this is j cap, this is k cap, and you want to find vector product of those unit vectors. So I cross j will be k cap. Okay, how? So take your right hand, put that right hand in direction of first vector, okay, and move your fingers towards second vector. So you move your fingers towards second vector and stretch your thumb. So your stretched thumb gives you direction of the third vector. Okay, the resultant. Okay, so if you do I cap cross j cap, so you put your right hand in direction of I cap, curl your fingers towards j cap and stretch your thumb. Your stretched thumb will give you k cap. Okay. Similarly, if you do j cap cross k cap, it will give you I cap. If you do k cap cross I cap, it will give you j cap. If you do this in opposite way, it will give you negative sign. Okay, but how to memorize this? So what I was saying is, if you do j cap cross I cap cross j cap is k cap, j cap cross I cap is minus k cap. Okay, so if order is reversed, then there will be negative sign. But how to memorize this is, you draw a circle like this, and then you take 3 points. This is your I cap, this is your j cap, this is your k cap, and then you draw these arrows like this. Okay, in clockwise sense. Okay, so you are taking vectors in clockwise sense, you're drawing arrows in clockwise sense. After that, if you do product of I and j, so if you are moving along the arrow, okay, I cross j, it will be what? The result will be k cap. Okay, but if you take j cross I, it will be minus k cap. So if you are moving along this arrow, it will be positive sign. I cross j is k cap. If you are moving against this arrow, so j cross I will be what? Minus k cap. Okay, similarly j cross k, if you are moving along the arrow, it will be I cap. But k cross j, if you are going in reverse direction, okay, against the arrow, then it will be minus I cap. So is this understood? Yes, no? Okay, here I want to talk about the origin of this force 3j cap, okay, which acts on a particle whose position vector is 2k cap. So what will we talk? So tau equals to r cross f. So r is 2k cap, 2 times k cap, cross, it is 3 times j cap. Okay, so 2 times 3 is 6. And what is k cross j? So this is important. J cross k is I cap, but k cross j, see this, k cross j, you are moving against this arrow, so it is minus I cap. Okay, so minus 6 I cap, 6 times minus I cap, so minus 6 I cap, and unit will be Newton meters. So this is the answer, option C. All right, this is simple. Okay, so only one student is replying still. Anyways, so this is simple. Just you have to memorize this trick. Okay. Then the moment of force F bar is given by this vector at 203 about the position 2 minus 2 2 minus 2 is given by. Okay. So what this question says is you want to find out torque or moment of this force about this point, which is acting at this point, about this point. Okay, so generally we find torque about origin 0 0 0. So you want to find talk about this vector. Okay, so you have this position, suppose 2 minus 2 2, and you are exerting your force at this point. Okay, so you want to find out torque about this point. So you have to take position vector with respect to this point and not with respect to the origin. So how do we find position vector with respect to this point? This is suppose point 1, point 2, and you want to find out position vector of, you want R21 bar. Okay, so what will be that? So let's say this is R2 bar, this is R1 bar. Okay, so if you take triangle law of vectors addition, you can write R1 bar plus R21 bar equals to R2 bar. Okay, this vector plus this vector gives you this vector, and you want this R21 bar because you are exerting force at this point and you want to find out torque about this point. So you are taking position vector of this point with respect to this point. Okay, so R21 bar will be equal to R2 bar minus R1 bar. Okay, and that is, so second point is at, no, second point is at 20 minus 3. Okay, so R2 bar will be what? 2 I cap plus 0 j cap, that is, we don't need to write it, minus 3 k cap, minus 3 k cap. Okay, so the point at which you are exerting force is this one, 2 I cap, 0 j cap, minus 3 k cap, and position of this point is 2 minus 2, 2 minus 2 minus 2. Okay, so it's here. So position vector of this point r1 bar is equal to what? 2 I cap minus 2 j cap minus 2 k cap. So coordinates are given. So from coordinates we can find out position vector. 2 I cap minus 2 j cap minus 2 k cap. So what will be r21 bar? It is r2 bar minus r1 bar. So let's do the subtraction. So r21 bar is r2 bar minus r1 bar. So it is 2 minus 2. So this will be 0. Then there is no j over here, no y component. Okay. So 0 minus minus 2. Minus minus is plus. So it is 2 j cap. And we have minus 3 k cap minus minus plus 2 k cap. So minus 3 plus 2. It is minus 3 plus 2 is minus 1. So minus k cap. So you got r21 bar now, and now you can use the formula. Okay. So what was the tricky point in this question? You are exerting the force at this point. So you can find out the position vector of this point, but you don't want to talk about the origin. You want to talk about this point. So what you have to do is, so you don't want to talk about origin. If you want to talk about origin, it will be just what? R2 bar cross F bar. But you want to talk about this point. So you have to take position vector of this point with respect to this point, which will be R21 bar, that is R2 bar minus R1 bar. Okay. So now once you find R21 bar, what will we talk? It will be R21 bar cross whatever is the force. R21 bar cross F bar. Okay. So let's do that. So torque is equal to R21 bar cross F bar, and that is, how do we find torque? It is Ijk, determinant Ijk, Rx, Ry, Rz. So there is no x component over here. Okay, so 2 and minus 1. So x component is 0, y component of R21 is 2, and z component is minus 1. Okay. What about the force? It is 4 I cap 5 j cap minus 6 k cap. So 4, 5, minus 6 are the x, y, z components. Okay, so 4, 5, minus 6 it was. Yeah, minus 6. And now let's solve it. So how do we solve it? So take I cap, hide the row and the column containing I cap, then you will be left with these 4 terms. So 2 into minus 6 minus 5 into minus 1. Okay. So it's I cap multiplied by 2 into minus 6. So 2 into minus 6 is minus 12, minus this 5 into minus 1 is minus 5. Okay. So let's erase this. Then this is x component. Then minus j cap, you put minus j cap. Then what you do? You hide this and this. Okay, the row and the column containing j cap. So it is 0 into minus 6 minus 4 into minus 1. Okay. So it is 0 into minus 6 is 0, minus 4 into minus 1, minus 4, and plus you have k cap multiplied by 0 into 5, that's 0, minus 4 into 2, so that is minus 8. Okay. So now it is minus 12 minus minus plus 5, so which is 7 I cap, minus is this will be minus minus plus. Okay, so plus 4 j cap, so minus plus 4 j cap, so again it is minus, and minus 8 k cap. So this should be the answer. 7I cap minus 4j cap minus 8k cap. 7I cap minus 4j cap. Yeah, minus 8k cap. So there is no option matching this. It was 6 into, oh, it was minus 12. Oh, it's minus 7, not 7. Yeah. So option D is matching. Minus 7I cap minus 4j cap minus 8k cap. So that is the answer, right? So D is the answer. So again, once again, if you wanted to find out the torque due to this force about origin, then the position of this force is given, coordinates are given. So you just find the position vector, okay, which is r2 bar. So 2I cap, 0j cap, minus 3k cap. That is 2I cap minus 3k cap. But since you don't want to find torque about the origin, you want to find torque about this point. Okay, this point, which is 2 minus 2 minus 2. So you need not take position vector with respect to origin. What you have to do is you have to take its position vector with respect to this point. Okay, so position vector with respect to this point will be r2 bar. And how do you find that? So it is r2 bar minus r1 bar. Okay, once you do that, you found, okay, r21 bar, which is r2 bar minus r1 bar. Now the torque of this force which is acting at this point about this point, so it will be this position vector multiplied by f bar. Okay, r21 bar cross f bar. All right, so that is the trick. Okay, yeah, hello Suji. All right, so let's move on to the next problem. A force F bar equals to this thing is acting on a point R bar equals to some vector. The value of alpha, where is alpha? Alpha, okay, it's here, for which the angular momentum about origin is conserved. So we know when the angular momentum is conserved. So we have seen when tau is equal to 0. But torque acting is 0, angular momentum is conserved. Okay. So we want to find out alpha, and it's given that angular momentum is conserved. So law of conservation of angular momentum says that when torque acting on a system is 0, the angular momentum is conserved. Okay. So how do we find torque? It is r bar cross f bar, and it's given that it is equal to 0. So let's find r bar cross f bar. So again, I, j, k, rx, ry, rz. So it is 2, okay, 2 minus 6 minus 12, right? So 2 minus 6 minus 12 and fx, fy, fz. So alpha 3, 6. Alpha 3, 6. Okay, so this determinant should be equal to 0. And how do we find it? So write I cap multiplied by what? Minus 6 into 6 minus 3 into minus 12. Okay, so minus 6 into 6 minus what? 3 into minus 12. All right, plus actually minus j cap multiplied by 2 into 6. Okay, so hide the row and the column containing j cap. So you're left with these four terms. So it is 2 times 6 minus 12 into alpha. Okay, so it is 2 into 6 minus 12 alpha, right? Plus k cap multiplied by this thing. So it is 2 into 3 minus 6 alpha. Okay, 2 into 3 minus 6 alpha, and this is equal to 0. Okay, so if this is equal to 0, what you have to do is you can take any component, because since torque is equal to 0, it's 0 vector. It means that all of its component are 0. So you take x component, y component, or z component. So if you take this, Okay, let's say I take z component. So it is 2 okay, tau x should be equal to 0, tau y should be equal to 0, and tau z should be equal to 0 because torque is equal to 0. Okay, so let's take tau z equals to what? 6. 2 times 3 is 6 minus 6 alpha, and this is equal to 0. That means 6 alpha equals to 6, 6 alpha equals to 6, and alpha equals to 1. This is the answer. So option B is the answer. Okay, is it clear to everybody? Is this thing clear? All right, so let's move on to the next problem. If F bar is the force acting on a particle having a position vector r bar and tau bar is the torque of this force about the origin, then so F bar is the force and it is acting at position vector r bar, and tau bar is the torque. Then these are the options. So r bar dot tau bar is greater than 0. Okay, see, this is very simple. We have seen this, that if you have vector product of two vectors, so we know torque is vector product of r bar and f bar, right? So this torque is perpendicular to r bar also and f bar also. Okay, torque is perpendicular to r bar also and f bar also. So angle between them is 90. So when two vectors are perpendicular to each other, their dot product is 0. Okay, because what is dot product? So let's say I take dot product of two vectors a bar and b bar. It is magnitude of first vector into magnitude of second vector multiplied by cos of the angle between those two. So if theta equals to 90 degrees, what is cos of 90? We know cos of 90 is 0. Cos of 90 equals to 0, and therefore this will be 0. So if two vectors are perpendicular, their dot product is 0. Okay, so here this resultant, as I said, it is perpendicular to r bar also, it is perpendicular to f bar also. Resultant of vector product is perpendicular to both the vectors. Okay, of course you are taking the product. Okay, so since tau bar is perpendicular to r bar and f bar also, r bar dot tau bar will be equal to 0 and f bar dot tau bar will also be equal to 0. Okay, so option B is the answer, right? Because in this option it's given that r bar dot tau bar equals to 0 and f bar dot tau bar is also equal to 0. Okay, and in every other option either it is greater than 0 or they are saying it's not equal to 0, something like that. Okay, so is it clear? Yeah. Okay, so let's move on to the next problem. Next problem is a particle of mass m moves in xy plane with velocity v along straight line AB. Okay, if the angular momentum of particle with respect to origin O is LA when it is at A and LB when it is at B, then okay. So particle is moving with velocity v and its angular momentum when it is at A is LA, when it is at B is LB. So now what will be the relation between LA and LB? So this is again very simple question, and the answer of this question is, see, there is no force acting on this particle, so that means torque is equal to 0, and if torque is 0, that means angular momentum is conserved. So L bar is conserved. Okay, so if L bar is conserved, it remains constant. That means LA is equal to LB. Its angular momentum is constant. So option A is the answer. Very simple. Okay, after that, let's move on to the next problem. The next problem is, which of the following statements are correct? Okay, there are four statements and four options. Center of mass of a body always coincides with center of gravity. No, this cannot be correct. Okay, center of mass and center of gravity are two different concepts. Okay, center of mass is the point at which total mass is supposed to be concentrated. Center of gravity is the point where the torque due to gravitational force is zero. Okay, so they need not be same every time. Okay, they can be same sometimes, but they need not be same. Then center of mass of a body is a point at which the total gravitational torque on the body is zero. Actually, this is center of gravity, not center of mass. So this is not correct, this is not correct. Okay. Then let's think about third. A couple on body produces both translational and rotational motion in a body. What is couple? Couple is two equal forces acting in opposite direction. Okay. So couple is two equal forces and they are acting in opposite direction. So then couple on a body produces both translational and rotational motion in a body. Actually, this is also wrong. Okay, and I guess the options are wrong. Okay, so couple produces only rotational effect, purely rotational effect. This is the property of a couple. Okay, couple is what? Two equal and opposite forces acting on a body. Okay, so see why they can't produce a translational effect. It is because if these two forces consist a couple, then they are acting in opposite direction, right? So let's say this is F1 bar, this is F2 bar. So what will be total force? So it is F1 bar plus F2 bar. Okay, and it is equal to 0 because their magnitude is equal and they are acting in opposite direction. So if sum of total forces is 0, then that forces, those forces cannot produce a translational effect. So translational effect is 0. So couple does not produce a translational effect. It produces only rotational effect. Okay. All right. So options 3 is also not correct, and that means all of these options are incorrect actually. Okay, and let's see the, anyways, mechanical advantage greater than 1 means small effort can be used to lift a large load. So this one is correct. What is mechanical advantage? So let's say you have a seesaw. Okay, and your seesaw is balancing at, it's not at midpoint, let's say. Okay, so now what you can do is, here is a big person, okay, a man or a woman whose weight is quite high, and here is a child. So now you can see that there will be some torque due to the gravitational force or weight of this child. How much will be that? It will be R2 bar cross his weight, okay, F2 bar, which is M into G, okay, acting downwards, M2 into G, and there will be some torque due to this person. Okay, this R1 bar, R1 is small, cross F1 bar. Okay, now this small weight, torque due to the small weight can balance torque due to the big weight, provided that this lever arm is bigger. Okay, so the ratio of lengths of these arms is known as the mechanical advantage. So what is mechanical advantage? Okay, it is effort arm. Who is putting the efforts? This boy, this child is putting efforts here. So effort arm divided by load arm. Okay, so this boy wants to lift this load of this woman or a man, okay, whose weight is much more compared to this boy. All right, so effort arm is this length, load arm is this length, so it is R2 upon R1. So this is mechanical advantage, and the boy will be able to lift that person if this ratio R2 upon R1 is equal to the ratio of the person's weight to that boy's weight. All right, so this option is correct. Mechanical advantage greater than 1 means that small effort, okay, you need small weight to lift greater weight. Small effort can be used to lift a large load. All right, so this one is correct, and none of the options unfortunately is correct. Okay, yeah, so it is in true sense none of this. Okay, so I think this is clear. Yes, no. Okay, so let's move on to the next problem. Next problem is ABC is an equilateral triangle. So this one is an equilateral triangle and O is the center. Okay, F1, F2 and F3 represent three forces acting along sides AB, BC and AC respectively. If total torque is 0, total torque is given to be equal to 0, then the magnitude of F3 is, what is the magnitude of F3 is the question. Okay, so now we know what is torque. It is R bar cross F bar. So this is the position vector. Let's use different color. This is position vector of first force. This is the position vector of the second force, and this is the position vector of third force. Okay, and since this is not origin, this is the center of this equilateral triangle, okay, where all the medians intersect. These three distances will be equal. R1, R2 and R3 will be equal. But now see, so R1 is acting like this, R2 is acting in this direction. So I can draw, this is R1 acting in this direction and this is F1. So there will be some angle between R1 and F1. Okay, R1 is acting along this line, right? Let's draw it like this. R2 is acting like this. Okay, so there will be same angle between R2 and F2. Okay, but see, F3 is acting like this. This is F3 and R3 is directed like this. This is R3. So if this angle is theta, this angle will be theta and this angle will be theta. Alright. So how much will be this angle then? This angle will be 90 minus theta. Okay. So this angle is going to be 90 minus theta. No, not 90. What did I say? It is 180. This total length is 180. Sorry, total angle is 180. It is 180 minus this angle theta. Okay. Is this much angle. This angle is 180 minus theta. Alright. So then sum of torques due to all these forces is equal to 0. So this is given. So F1 R1 into F1 sine theta, this is torque due to first force. So we are given tau1 plus tau2 plus tau3 is equal to 0. So it is equal to R1 F1 sine theta plus R2 F2 sine theta plus R3 F3 sine of 180 minus theta, because angle between R3 and F3 is 180 minus theta. Okay, and this is equal to 0. Okay, all this is equal to 0. But R1 is equal to R2 is equal to R3. Okay, so R1 equals to R2 equals to R3. Let's suppose it is equal to R. Okay, so it is R, you can take common. So R into F1 sine theta plus R into F2 sine theta plus R into F3. Now sine of 180 minus theta. Sine of 180 minus theta is minus sine theta. Okay, so this is minus sine theta is equal to 0. And then you can take R and sine theta common. So if you take R and sine theta common, then you are left with what? F1 plus F2 minus F3 from here. So F1 plus F2 minus F3 is equal to 0. Take R sine theta on other side. So it will go in denominator. That means 0 upon something is still 0. So F1 plus F2 minus 3 is 0. Okay. So F1, the magnitude is it equal? Okay. So F1 plus F2 minus F3 is equal to 0. So that means F3 should be equal to what? It should be F1 plus F2. Alright. Which one is the answer? Option A is the answer. Okay. So yes, this is not a difficult question, but little bit lengthy, you can say. Alright. Okay. Then let's move on to the next problem. A solid sphere of mass m and radius r is rotating about its diameter. Okay, solid sphere and then a solid cylinder of same mass and same radius is also rotating about its geometrical axis with angular speed twice as that of sphere. The ratio of their kinetic energies. Okay, so yeah, this point I didn't teach today, so we'll take this question tomorrow. All right, let's move on to the next one. A light rod of length L has two masses m1 and m2 attached to its two ends. The moment of inertia of the system about axis perpendicular to rod and passing through the center of mass is. So you have a light rod, its length is L, and there are two masses m1 and m2. They are attached at the two ends of this rod. The moment of inertia of this system about the axis perpendicular to the rod and passing through the center of mass, not midpoint. Okay, center of mass. So first of all, we have to find out the center of